welcome to my class. In this video, we are going to be solving A-level question on rate equation. Let's consider the question on the board. The table below shows the results of 3 experiments carried out at the same temperature to investigate the rate of the reaction between P and Q. Then the question under the table says that use the data provided to deduce the order with respect to P and Q. Then the rate equation is derived from reaction rate. Then the reaction rate is directly proportional to the concentration of the reactants. Now we have a chemical reaction between P and Q. These are the reactant particles. We have a chemical reaction between P and Q. So let's say the product of P and Q equal to S. Then we should not forget rate equation. It is derived from rate reaction. And rate reaction is directly proportional to the concentration of the reactant. We only deal with the reactant side, the concentration of the reactant. So that is P to the power of the number of mole of P. Let's say the number of mole is X. That the number of mole of Q, let's call it Y. So P to the power of the number of mole of X. So this number of mole, this X, is known as rate order or reaction order. So we are looking for the reaction order, which is X. Then the other reactant, that is Q, to the power of the number of mole, which is the reaction order for what? For Q. So this is our rate equation. Now we can transform this rate equation into R equal to this sign of proportionality will change to constant K. It will change to constant K into P raised to power X. Then the other reactant Q raised to power Y. So they've given us what? Concentration for P. We have concentration for P. We have concentration for Q. Then the initial rate is known as the rate of reaction. The initial rate is the rate of reaction. Now we are looking for the what? We are looking for the order with respect to P. Let's start with the order with respect to P. We are going to calculate the order with respect to P first. So let's first calculate the order with respect to P. Now, when you want to calculate order with respect to P, you are going to consider the what? The concentration under Q. I want to calculate the order with respect to P. I'm going to consider what? The concentration under Q. Then you are going to look at where you have what? Constant concentration. You are going to pick 2 different experiments with constant concentration. Now let's come to Q. I'm looking for P now. I will consider Q. Now I will pick what? 2 different concentration, 2 constant concentration from Q. Now at Q we have what? Constant concentration in experiment 1 and experiment 2. This is experiment 1, this is experiment 2. We have constant concentration at 1. We have constant concentration at 2. So we are going to compare these 2 experiments in order to get the rate order for P. So let's compare these 2 experiments. Compare experiment 1 and 2. For the order with respect to P. For the order with respect to P. Now let's come back to our rate equation. Now we consider 1 and 2. We are going to consider experiment 1 and 2. So we are going to derive equation for experiment 1. Then we derive equation for experiment 2. So let's do that. So let's consider experiment 1 first. So the concentration for experiment 1 equal to Q. Then they've given us the rate of reaction for experiment 1. The rate of reaction for experiment 1 is 7.5 times 10 raised to power minus 3. So let's write rate reaction, which is R, is 7.5 times 10 raised to power minus 3. Then equal to, so we don't know constant K, which is rate constant. So constant K, then into bracket, what is the concentration for P? What is the concentration for P? P is 0.50. 0.50. Then to the power of what? Of X. Then let's consider Q. Let's consider experiment Q. So we have concentration Q equal to 0.36. 0.36. So 0.36 to the power of what? To the power of Y. So we call this one what? Equation 1. Let's consider it to be equation 1. Then we are going to write rate equation for experiment 2. Let's move to experiment 2. The rate of reaction for experiment 2 is 1.9 times 10 raised to power minus 3. 1.9 times 10 raised to power minus 3 equal to, now we don't know the constant value. We don't know the constant value. So let's call it K. Let's call it K. Then into brackets, the concentration of P under experiment 2. The concentration of P is equal to 0.25. So 0.25. Then to the power of what? Of X. Then the concentration for Q is what? Under experiment 2. The concentration for Q is 0.36. 0.36 to the power of Y. So let's call this one equation 2. So now, don't forget that we are looking for rate order. We are looking for the reaction order for P, which is X. So we look for a way to make X unknown. We make X the subject of the formula. So what are we going to do? We are going to use equation 2 to divide equation 1. We are going to use equation 2 to divide equation 1. So equation 1 now, that will be 7.5 times 10 raised to power minus 3. Then divided by what we have in equation 2. 1.9 times 10 raised to power minus 3. Then equal to equation 1 divided by equation 2. That will be K into bracket 0.5 raised to power X. Then is 0.36 raised to power Y. Then divided by what we have in equation 2. Divided by K into bracket 0.25. Then to the power of X. Then is 0.36 to the power of Y. So K cancel K. So 0.36 to the power of Y cancel 0.36 to the power of Y. So 10 raised to power minus 3 cancel 10 raised to power minus 3. At this side, we are going to use this 7.5 to divide 1.9. 7.5 divided by 1.9 will give us 4. Then equal to, at this side, we are left with 0.5 raised to power X divided by 0.25 raised to power X is 0.5 divided by 0.25. Then let's say everything raised to power X. Everything raised to power X. So 0.5 divided by 0.25 will give us what? So 4 equal to 0.5 divided by 0.25 will give us 2. So that will be 2 raised to power what? 2 raised to power X. So let's apply law of indices. Let's apply law of indices. So we are going to equalize what you have at the base. So I can change this 4 to 2 raised to power 2 equal to 2 raised to to the power of 2 equal to 4. So equal to 2 raised to power x. So these two we cancel 2. Then x equal to what? X equal to 2. So the order with respect to q, the order with respect to q equal to 2. The order with respect to p, the order with respect to p equal to what? Equal to 2. So let's look for the order with respect to q.